All right, well, hey everybody. This is Astronomy Daily Live, and we're here again, gathering together, group of friends from around the world. And I told myself I wasn't going to do that today, gathering together, and I did anyway. And I told myself I wasn't going to do that today. There we go. Okay. All right. Well, yeah, from around the world, it's absolutely spectacular. You know, as primitive as this is, right? And I see this as pretty primitive, right? It's pretty incredible, right? And it's this is sort of the first time in the history of humanity that we're each of us, right, is sort of in this position of being able to uh, be in some kind of contact with anyone else on or off planet, right? And that's pretty amazing, you know, pretty incredible. Um, so yeah, this is what we're doing every single day, starting at 2 hours UTC, and usually going for about an hour. It's just a casual, fun get together of friends, like minded individuals who share a common passion for the science of astronomy and, you know, science in general, right? It's a pretty interesting area to be in. You know, those of us who are in it, it's sort of like, well, this is just how life is. And yeah, I mean, I can't possibly imagine, uh, you know, having a life without this kind of scientific understanding. Uh, um, I It would definitely be different. I have no idea if it would be any better or worse. Um, but you know, there are people, most people, right? The vast majority of people do not have science in their life whatsoever. No, nothing, right? Um, and I can't I can't personally comprehend that. So this is a place to share that passion, and it's an ever-growing crowd. Subscribers continue to sort of go up, 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 up. You know, very small steps. Number of views. I don't know what it's doing there. Sometimes I have, you know, quite a few, and sometimes I have barely any at all. And you know, I've uh, I've watched a couple of those YouTube things, you know, talking about, you know, how to you know, uh, look at the stats of your videos and all that, and you know, see if one stood out and all that. And it's like mine don't do anything; they're just all over the place. Anyway, speaking of all over the place, there is a Bobby on the panel. Hey there, Bobby.
Hey,
What is going on?
nothing much.
Now, did you get any of Florence at all? Or are you too
No,
far south? You're way
I'm
too
just
far
too
south.
far south.
Yeah, okay. All right. So you didn't even get into the clouds or anything.
No.
Way too far. Okay, cool. All right. Well, you know, before the live stream started, Bobby and I were talking again about yesterday's conference, you know, the SpaceX conference, and so I was just wondering if anybody in the chat had any like additional thoughts or observations or things that you sort of heard today. Um, uh, and let's take a look at those. I really haven't given it much thought today at all, so I don't really have anything new to to add. And Daniel, nice to see you.
And I was really thinking if all goes out very well by 2023 and he sends his people off to the moon and back, I think that would be a great adventure that we can have. And maybe we can expand to like Mars and pretty much out of the solar system and stuff.
I mean, it's absolutely true, right? That we really have to have a reason to go, and and you know once we put our feet on the surface, um, that was our reason to go, right? I mean, there are lots of reasons in there, right? But I mean, that was the main thing, right? Was to walk around, to drive around, grab some samples, you know, do all those kinds of things you should do when you're exploring, right? But then it's like, well, okay, well, what do you do then, right? And I think some of it is technological, right? I mean, we're always getting better at the technology, making things smaller, making things faster. Um, capacities are larger. All of that, right? And it's growing. It's probably growing exponentially, right?
Now, when the Apollo missions came along, and there were so many issues, we're like not ready to go to the moon or go further on down in space, or we're ready now?
Well, I I think that regardless of when it happens, um, when it does, we are definitely ready to go. So I think using 1960s technology to go to the moon compared to now, there's no comparison whatsoever. Um, but you still have these fundamental uh, natural problems, right? You've got to get yourself uh, out out of the gravity well of Earth, right? At least enough to be able to sort of shoot yourself out to the orbit of the moon. Um, so yeah, yeah, I think. I mean, and we can definitely do it now. We just have to have a reason to, and tourism is most definitely a very, very, very good reason to do it, right? There's maybe a lot of opportunity there, but I don't think that we've actually figured a lot of that out yet. We really don't know what it's going to be like, having some kind of permanent presence on the moon, right? Um, yeah, I don't think that we really know what that's like yet. Is it like living in the space station, or is it something more than that? I don't know. I mean, because if it's similar to living in the space station, well,
It's very great when many organizations wants to go back to the moon.
yeah, yeah. I think when there is uh, when there's a desire from the population to go to the moon, we will go to the moon. Yeah, simple as that. So, and I think that desire is growing.
I like to know if like have you seen Apollo 18?
Have I seen Apollo 18?
Yeah, the movie.
No, never heard of it.
Yeah.
Hmm.
Um, um, I don't I don't think that even happened and stuff. But you never would know when it comes to censorship and all that.
Okay, is this like some kind of not necessarily
One of these
conspiracy?
conspiracy theory things that the FBI
I
has and stuff.
I gotcha. I gotcha. Yeah, yeah. You know, it's I you know
That movie was pulled off from a website.
hmm, yeah. You know, I I think that you know I guess you just sort of have to let people think whatever they're going to think, and don't at least I don't try too hard to convince anybody of things. Um, just because I just don't want to make the effort. Um, you know, if people think sort of odd things, it's like, well, I probably think the same kind of odd things anyway. So it all sort of evens out. Let's see, Daniel. Yeah, well, they want to push the envelope, right? They think that they've got satellite launching down pretty well, and they think that they've got reusable cores um, as well. So if they think they've got that, I think the one thing that they really, really, really want, and they either don't have an opportunity to do it or they miss, is catching the fairings, right? After I think it's usually right after the uh, the first stage drops off and the second stage fires. I'm talking about the Falcon 9. But most of the rockets basically do exactly the same thing. Once it gets to sort of that last stage, whatever the last stage is, it'll pop off the fairings at the front of the rocket. And of course, that's where the...
Now, is SpaceX working with NASA?
Oh, absolutely, yeah. Yeah, they're contracting with NASA to deliver um, uh, pods to the space station. And I think
Now, when it
they've...
comes to conspiracy theories, do you think there's a source, or sometimes you may think that that's not true?
Oh, I don't know. As I said, I sort of let people think whatever they want because they don't have the information and experience that I have, and I don't have the information and experience that they have. So you know, and then it depends on how you interpret things. It gets really complicated, right? We humans love to complicate things, and
Now, I saw a series they used to have on the Sci-Fi Network called Fact or Fake Paranormal Files, and I think that was a great show.
very cool. So Daniel's
The
asking,
Destination Trip was another good one as well when it was on Sci-Fi.
cool. So Daniel's asking about if SpaceX is working closely with NASA. Yeah, yeah. I would say they're working very, very closely with one another. And if for no other reason, NASA sort of wants to peek under the covers, to see what's going on and be able to participate in that kind of development too. I mean, it's a great time to, well, I think we're going to get into an era of competition, right? I mean, Elon actually talked about this last night, right? And so I think we are going to be into an era of competition between companies, right? Because there's at least three companies that I can think of off the top of my head um, that is going to be soon putting, in the next 10 years, be putting people in orbit and on the moon, or around the moon. And that's SpaceX and Blue Origins and Boeing. So yeah, I think they'll hopefully they'll all do it. I'm an advocate of just getting out there, just getting out there. It's I don't I think that going into space and being in space is absolutely fantastic, right? And if I were asked to go, I would most likely go as long as I can come back, right? You gotta sort of guarantee that. But besides that, it's like sure. Um, so I think it'd be very, very cool. But is it really any better than being here or on the moon or on Mars? I mean, uh, yeah. I mean, being happy in a place has a little bit to do with the environment, but it has a lot to do with yourself. So, yeah. Do I have a desire to like live in space, live on the moon? Mm,
Now, if they can
probably
achieve
not.
that goal, now if they can achieve that goal, how long is it going to be until we do have like a colony in the moon on the moon?
I think as as soon as we can find a good enough reason to do that, we will do it. And are there good reasons? Mm, there's no infrastructure, so that's a little bit hard, right? I mean, if you want to do like mining, right? If you want to do mining on the moon or mining on an asteroid, you have to have certain machines that may not even exist, right? You might have to take a machine that we have now and modify it, right, in some weird way. And then, fine, you've got these machines to mine your iron ore from some asteroid, right? That's maybe as much as 50% iron, right? Which isn't really good enough. So you have to have a way to smelt that, right? You got to go back to the bottom of the food chain here and realize that we're going to need
Now, what can
infrastructure.
actually stop you from actually going straight to the moon and or other parts of space?
What is stopping me, or what is stopping sort of us?
What's stopping us?
It's it's right now it's very, very, very expensive to put objects into space. I think, as I said, I think Falcon 9 has brought it
I
down.
thought it was like the government and stuff like that, but you may never would know.
Well, regardless of who is paying for it, every single launch has a certain expense, right? A bottom line. It's like this is how much it costs, right? And that cost, uh, I think, on SpaceX Falcon 9 right now is something like $10,000 per payload pound.
And
So not
if you was checking the chat, I think like Daniel's got a point, and probably Otto as well.
I'm going to eventually have to find another place to live. Yeah, yeah. I think um, somebody was talking about that just the other day, um, about um, exactly what you're talking about there, um, Atta. Uh, this idea that, we need to, you know, uh, get off of this single object. So in case of disaster, right? Because as I said, and I'll continue to say forever, right? There are multiple asteroids and multiple comets that have our name on them. They are going to hit us one of these days. Now, most of those objects, in fact, all of those objects that I just mentioned, um, we haven't found yet. We don't even know that they're there, but they are. So yeah, it's just a matter of time. Just a matter of time. So with that, I mean, if we have this desire to continue the species, right? Which it's like, okay, then we need to, you know,
Now, what should be in your top priority, the moon or try to get rid of space junk?
oh, I don't know. I think the space junk thing is a commercial opportunity, just waiting. That's like low hanging fruit. That's like the easiest thing.
I watched something one time when I was like back in my school days about what if an object does to hit the ISS.
Yeah, well, it depends on their relative speed. You don't want anything running into it, but most objects are actually going to be sort of well, many objects uh, are going to sort of be in the same orbit, right? But there are going to be other things that aren't, and those are the ones that are going to give you a lot of trouble. So yeah, it could be pretty disastrous. A pea-sized object, like a nut or a bolt, that would yeah, that would be pretty serious. Yeah, that would make a big hole, big hole. So yeah, so there's that, right? There's this need to protect the species, right? But there's also this very very strong desire to explore, to just to go and to see and to find out what's going on, you know, as far away as you possibly can. So yeah, it's sort of those two things. Up there with all the junk floating around. Yeah. Yeah, there's a substantial amount of junk from, you know, little pieces of metal like foil, to larger objects like nuts and bolts, screwdrivers, um, uh, anything, right?
Now, how many space stations do we have, with the exception of the International Space Station?
Well, there's one other space station in orbit around the Earth right now, and that one's Chinese. I think. Oh, is there a South Korean? There might be a South Korean. Somebody check me on that. Um, yeah, yeah. And actually, I worked on that problem 15 years ago. The Air Force at that time hired the company that I was working for to create a worldwide network of automated telescopes that would scan the sky, looking for moving objects, and you know, track them, determine their orbits, and then see what they're up to. So yeah, it was a project to detect and characterize those objects, and most of those objects were going to be space junk, because you know I think at this point I don't think anybody is tracking anything smaller than maybe the size of a mug or so. They just don't. They don't have the capabilities. They don't have the technology to do it. So yeah, I don't think that they're seeing anything smaller than a mug. Maybe slightly smaller, but we were detecting objects down to 1 centimeter at geosynchronous orbits. So they're very, very, very faint, very, very, very faint, but well, and not necessarily moving very fast either. So that makes them easier to spot. But yeah, and the space. I mean, what's happening now? And I like hearing Elon talking about the problem of space junk, and what SpaceX is trying to do is to guarantee that anything that they fling up there, it's going to come back down in like 2 years. I think 2 years or less, or 5 years or less, or maybe it's more than that. Maybe it's like 25 years or less. But whatever it is, I think that's a good idea, right? I mean, if you can do things to give your rocket body a little drag, then it's going to come down a little bit sooner. I mean, let's do this. We can look at the rocket bodies or the satellites that are going to be moving over my location, well, right now, and let's just see how many RBs there are, how many rocket bodies there are. So I'm going to share my screen. Always like to share my screen. Hi. And we're going to go over here, and we're going to go to Heavens Above. And let's see, I'm going to provide an approximate location, just because I am so incredibly secretive. Whoop. Oh, I lost him. Here we go. Definitely in southeastern Arizona. Let's just plant me over here. There we go. Close enough. Close enough. So let's update this. Okay, so now I have a location, which is close enough to me that these times and everything. So if we go to daily predictions for brighter satellites, it should pop up all the satellites. And let's go all the way down. Let's go down to 5th magnitude. And let's just see all the rocket bodies and debris. Rocket body, rocket body, rocket body, rocket body, rocket body, debris, rocket body. Dun, 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 dun. Here's a few satellites in here. Yay. Rocket body. HST. Oh, cool. HST went over me. rocket body, rocket body. So, I mean, all of these rocket bodies are space junk that need to come down. Look at them all. This is just tonight. So yeah, it's pretty amazing how much big junk is out there, right? Just imagine how much little junk is out there. Especially, you know, when it was back in what 2004, 2005, the Chinese decided to collide two of their satellites at like 900 kilometers up. So that stuff is going to be up there forever. And you can imagine a million pieces, right? I mean, it's got to be at least. So, yeah, that was really, really dumb. But, you know, I guess they were maybe trying to make a point. I don't know. Anyway, so yeah, lots of junk out there, and we can see it. And as I said, I think we're tracking it. I'm doing the wrong buttons here. Stop sharing. So yeah, I think that NORAD is tracking objects about that size, 10 centimeters. I think is what they're doing. And I think now, of course, they use radar, right? So they're using radar to do that. The system that we had actually used telescopes, just sort of special telescopes, but not very big. They were I don't know, maybe 4.5 inches, 6 inches. I'm not exactly sure. So yeah, pretty amazing.
On a lot, we're going to start to look like Saturn rings, in our case, of junk.
Cool. Yeah, it's a problem, and you know, the traffic in space is very, very soon going to get at least an order of magnitude worse, because this you know, I'm sort of torn on this one. That same Elon Musk and that same company SpaceX wants to provide worldwide one gigabit internet for anyone in the world at a reasonable cost, right? He wants to price it way down, and everybody will subscribe, and yeah, it'll be very affordable and very fast, and it's going to be worldwide.
Now,
So,
Daniel Brownie, so if you're taking a short trip to the moon, you have to fly through the stuff. Then again, well, we get through the asteroid belt most of the time.
yeah, you know, Daniel, there isn't very much stuff between the Earth and the moon. It's not much stuff, really at all. And we can account for the larger things and not run into them at all. Most of the rockets that are fired to geosynchronous orbit is about as far as any satellite is going to go. Now, there's exceptions. There are the Lagrange points, L1, L2, L3, L4, and L5. And I think that there might yeah, I think that there are definitely some spacecraft located at some of those Lagrange points. Um, JWST, the James Webb
Now the
Space
asteroid belt
Telescope.
is not really very crowded, unlike the movies.
Yeah, yeah, exactly. So yeah, there's not much between here and the moon, so that's not a big deal. And yeah, space is big. Space is really, really big. Meaning that there's a lot of space in between things. So yeah, what's how uh, uh, asteroid belts are sort of portrayed in the movies. Mm, no, no. I mean, we now know of almost 700, almost 800,000 known asteroids, and that is growing every single day. Every single day, they grab a few more, a few more, a few more. So yeah, yeah, we'll just have to see how the space junk thing. It turns out that the last episode of Tomorrow, TMRO, spoke to the I don't know. I think it's the chief operations um, um, officer, the COO of a company that actually does want to clean up out there, and they think they have a plan. I want to listen to that one again. Hey there, Chris. Nice to see you. Nice to see you in the chat. So Chris Astro, he is doing. I don't know how frequently, but he has been doing some live streams, looking at the moon, looking at other objects, and just basically chit chattering about various astronomical topics, and oftentimes nothing to do with astronomy at all. So yeah, well, thanks for coming in, Chris. That's very, very cool. So check out Chris's YouTube channel if you haven't already. Um, let's see. Can I do this? I think I probably can. I think I probably can. Let's see. I'm going to go to my.
And I just subbed him up, so welcome, Chris. I just subbed you up.
Yeah, excellent. I'm going to. I'm going to try really, really hard here to. What is it? It is Chris Astro channel. I'm just going to provide everybody with the link. And yeah, I really like what he's doing. I really like it. I like the format. I like the nice, cool, laid back atmosphere. Yeah, I like it. And you've got some good optics and a good camera. There you go. Yeah, yeah. So Chris is pretty awesome. Check him out for sure.
Now in the chat, you can actually click on like the three dots, or if you're on the app, you can click on the channel icon, and there's an option there where you can go straight to the channel and stuff. That's how I did it.
Yeah, yeah. I think you can either do the three dot method or the little picture method. Yeah, yeah. Well, now that I've turned on notifications to let me know when you're going on, Chris, I get a little message here, and I'm like, okay, well, cool. He's on. I'm gonna jump over there. So yeah, I'll definitely be trying to visit you as much as I possibly can because excuse me, I want to see what else you're doing. Cool. Yeah, nice, nice, sweet. Yeah, the moon. I mean, as you know, for sure, the moon is an amazing place, and it's very much taken for granted. But yeah, it's quite an amazing object, um, and where did it come from, and why is it there, and how is it, how what role did the moon play in sort of the development of life, and um, yeah, who knows? Yeah, the photography is really, really nice. As I said, he's got a nice setup for sure. So yeah, check him out. Check him out for sure. All right, well, cool. I wanted to jump back onto that supernova paper by Adam Burrows. Just because I wanted you to see what these guys are up to in terms of trying to simulate the fractions of a second after a supernova explosion, and um, Adam Burrows has been working on this problem for decades, and like I was saying yesterday, um, Adam Burrows is the genius of geniuses. I mean, he's just it. It's just, I mean, your jaw just drops on the ground, right? I mean, I had him for a class. It was a senior level uh, um, mechanics course. I guess mechanics, is that the right term? Just Newtonian kinds of things, but at a senior college level, and every single
I think we
day.
are pretty sure of where the moon came from and how it influenced the chance for life on the planet.
Yeah, I don't know. I mean, like I say with everything, Atta, it's a good story, right? It's a good story. I like the story too. Seems to, our we we can plug in various values and change various parameters inside of models to predict the situation we're in, or at least we think we're in, when it comes to the moon, right? Number of craters and distance and masses and all that. And the models do seem to match the observations. So I'm not quite sure what the confidence level is, though, in terms of those models, right? How do you measure that, right? Because nature has provided us with a situation where there are oftentimes multiple ways to solve one problem. And so, okay, maybe all the numbers and all the dials, if they're set just like this, right, then there's a match. But if you change those numbers, change the dials around, you can get another match. And maybe that's the right one. I don't know. I don't know. I mean, as you see, you know, sometimes when we go through papers that are more theoretical, right? They're they're talking about their models and how they created them and what kinds of parameters there are. And most serious astronomical models, right, are incredibly complicated, both mathematically, right? They're mathematically complicated, but ultimately you have to convert this into computer code, right? So it gets incredibly complex really fast.
Yeah. So Chris Astro Channel. There's theory that more-sized objects smash into the Earth, causing the to form, the debris to form as the moon, and that's why the Pacific Ocean is so deep.
Yeah, and you know, as I said, that's a good story. It's a good story.
It's
It seems to match the observations. I just, I like to keep a open mind and a skeptical mind on anything, especially, a red flag for me is you know we're sure about this, right? When I hear that just, I mean, I have to I have to laugh because it's absolutely ridiculous to think that we have any answer to anything whatsoever. It's ridiculous to think that. So
Now it's kind of a bit crazy. I think there was something one time on that on a radiogram show on shortwave. They were talking about there were like so many more planets when the solar system was just beginning to make its presence known than to now.
yeah, the story of just the solar system. I mean, even the current one, right, is an epic story. I mean, it's absolutely amazing, right? And we, we don't have a complete story, right? Not even that, right? We sort of, fluff over a lot of things um, because we just don't know. But even the current story of just this little portion of the universe is epic, right? Is epic. Um,
And I think Arthur has a point. Nothing is sure. Every scientist knows that.
yeah, well, you know, I I'm not so sure about that because I mean, you sort of term that confidence level, right? So how and these kinds of things aren't really discussed much and should be a little bit more. Um, Now they're talked about you know in the papers, but and that is this idea of how confident are you in the results, right? And that's where I think sometimes that confidence level gets a little too high, a little too high. It's like you know, look, our models predict that the rotational motion of galaxies is going to be like this if we include dark matter in the model. Okay, and then we compare that prediction to what we observe, and it's a good match, right? But as I said, these models are usually very complicated, right? Many variables. I mean, could be thousands, right? And they all interact, right? They all
Now, how long do you think that the universe will be definitely be out of gas of everything.
I I I'm not quite sure. I mean, if you follow the current story, then I think the prediction is it's there. There's going to be something for at least the next 100 trillion years. But if entropy is true, then um, uh, that kind of thing is going to happen one way, one way or another, right? We have no way of stopping it at all. So that is the end game. The end game is, at least according to the current story, right? The end game is just nothing, nothing at all. So now, do I agree with that? Probably not, because I've got an intuition that that kind of thing throws up one of these red flags, right? And it's like, I don't know.
There's a really such thing as a multiversal system.
Is there? I
Like
think,
there's a such thing as a multiversal system.
yeah, I think that comes down to maybe sort of a matter of perspective. Um, it's it seems to me that a multiverse is really, really hard. It's hard to keep up with it, because at every moment, right, every Planck time moment, right, 10 to the negative 30, 43rd seconds, something like that, um, uh, a new universe is created, a whole one, right? And so, in 1 second, right? So putting it another way, right? In 1 second, 10 to the 43rd new universes have been created and are sort of doing their thing, right? Now, I think that sounds pretty complicated. That sounds like too complicated. So I'm I'm skeptical of everything. That's a fact. But I'm sort of that seems like a funny story that's hard to wrap my head around. And I don't think that you necessarily have to have an understanding of things for them to be true or real. Um, but yeah, you know, if you consider how many seconds, uh, again, if you follow the story, right, this universe, this particular one, is about 13.6, 13.8 billion years. Well, how many seconds is that? Well, you take that number of seconds, you multiply it by 10 to the 43, and you get how many universes have been created since this universe started. I don't know. That seems very excessive. I don't know. But the universe is full of excessive things, right? I mean, it's amazing to imagine that there are 10 to the 23rd molecules right in here. And that's a very big number, right? That's a very big number for what we consider to be a relatively small space.
Yeah.
So yeah, maybe we're just not there in terms of being evolved, right? And but I think we have some great ideas, and you know, do we have a better idea about what the universe is like than we had 1,000 years ago? Yeah, I mean, I guess you have to define better, right? Um, so yeah. Anyway, let's. Oh yes. Electric Universe. Yeah, I've looked into them um, pretty hard, and they have a very strong argument. Very strong argument. Yeah, I think they are definitely um, onto something with that. Um, the problem that I have right now with the Electric Universe is that um, they need to come up with observations. Um, right now, they're sort of on a kick trying to uh, sort of embarrass science, and I don't think that's the right tactic, because I think we should just use science and go where it shows us things. And if it's showing us things in this electric universe, then let's pursue it, right? I mean, don't throw it away. An electric universe is nothing as far as I can tell like flat Earth, right? Flat Earth um, requires something to physically change, right? There's a physical difference between a spherical Earth and a flat Earth, right? With the electric universe, nothing changes. Nothing actually changes. What changes is the perspective, is sort of the cause, right? Why are things behaving the way that they are? So yeah, very, very different than the flat Earth, but yeah, it is definitely something that you all should check out, because, as I said, I mean, do they have the answer? No, I can't. I can't give them that, and I can't give sort of conventional science that either. I just can't. Um, but as a viable, you know, as a viable alternative change in perspective, yeah, I think it's pretty viable. Um, here's a pretty. Here's their main site called Thunderbolts.info, and they have a YouTube channel as well, which yeah, you should definitely check out for sure. If nothing else, these kind of alternative um, ideas about how things are, you should take a look at them. Don't just throw them out because they go against what you think is true or right. Everything, people put a lot of effort into what they're working on, and that, I think, that demands respect. So if they're wrong, or if they're malicious and lying and all of that, well, that's one thing, right? But almost regardless, a huge amount of effort goes into this work, to look for alternatives to the conventional thing. And as far as I'm concerned, that's good science. That's really, really good science. And so I'm totally in favor of that. And yeah, as I said, the electric universe has some interesting arguments. Has some interesting arguments that it's like, well, don't know. Oh, well, let's see. Let's look at Adam Burroughs's paper really, really quick. I just, we'll look at the abstract, and then we'll look at the pictures, and that'll be it, because the pictures are absolutely gorgeous. When I first saw him doing this in the early 90s, the pictures were beautiful then, but compared to now, no, they were pitiful, sad things. So yeah, let's take a quick look at that paper. If it's going to let me. There we go. Taxing the machine here. Let's see. I'm going to pull that up, and I'm going to pull that up. So a successful 3D core collapse supernova explosion model. And yeah, Adam Burroughs is at Princeton, New Jersey. Amazing guy. Totally amazing. Now I'm going to hide that. So in this paper, we present the results of our three-dimensional, multi-group, multi-neutrino species radiation hydrodynamic simulation using the state-of-the-art code Fornax of the terminal dynamics of the core of a non-rotating 16 solar mass stellar progenitor. Let's see. The calculation incorporates redistribution of inelastic scattering, a correction for the effect of many body interactions on the neutrino nucleon scattering rates, approximate general relativity, velocity-dependent frequency advection, and an implementation of the initial perturbations in the progenitor core. Wow, it just goes on and on here. 100 milliseconds of bounce. So yeah, these are very, very, very small time scales, right? So yeah, the end of the simulation is, or the entire simulation is less than 3/4 of a second, right? It's like 2/3 of a second. Explosion energy of 2.5 times 10 to the 50th ergs per second. I'm trying to remember. I wonder if we do a search for the sun. Oh, it's going to give it in. Yeah, I don't think it's going to give it in ergs. I was trying to see if there was a number about how many ergs of energy the sun puts out, ergs per second. But I'm not seeing that anywhere. Oh. No. Okay. Oh well. I don't think there's anything here. Their size, physical. There is a luminosity, but it's in the wrong units. So I'm not sure how to convert watts to ergs per second. So, oh well, that's all right. That's all right. Let's go back here. That's a lot, I would say. That's a pretty big exponent, right? That's 2.5 followed by 50 zeros. So that's sort of a big number. So the supernova explodes with an asymmetrical multi-plume structure with one hemisphere predominating. Huh. So the gravitational mass of the neutron star at 677 milliseconds is 1.42 solar masses. So that thing is going to blow off, 14 solar masses. Wow. So yeah, this is a great paper if you want to get an idea about what goes into creating a model. And these are very complex, right? These are extremely complex.
What the?
Let's see. Uh-oh, I hear doggies in the background. Doggies in the background. I'm going to mute that. There we go. So, yeah, as I was saying, this, if you want to gain an appreciation for creating a model and what goes into it, it's this is a very, very good example. Very good example. And I expect nothing less from Adam Burrows. Believe me, this was meticulously gone over by all of them. So yeah, let's just here. I think there's a couple of appendices which are kind of interesting. Here's all the references, which is also extremely interesting most of the time. So here's the approximate general relativistic formulation. So a little bit of calculus, partial differential equations. There's nothing too heavy here, right? I mean, it's all, a lot of this is more algebraic than anything else. Although, of course, a lot of information is packed into these little equations. So, imagine, right, coming up with this mathematics, right? Coming up with this mathematics. And then having to write software, having to write code to implement these algorithms. Ton of work. Ton of work. All right, so here, let's...
Yeah, I'm sorry about that. My uncle just slipped and fell in a wet spot.
Oh, he okay?
Yeah, he's all right, but it really hurts.
That's not very nice. Well, hopefully he'll recover. We're just looking at the at these supernova explosion models, and I think they're fabulous. Oh, that's as big as it goes.
All right. I think Octolot's about to get going because she won't be here tomorrow, but she's looking at a clear sky tomorrow.
That is fabulous. I hope that there's a clear sky. But yeah, take a look at these. These are just the sort of the material, right? The simulated material blowing out from this explosion. I just like the colors.
Kind of interesting.
Yeah, this is what a supernova explosion looks like after 690 milliseconds after it implodes and so-called bounces. And these are 3D too, right? So I mean, we're just seeing it in 2D here, but you can actually rotate these things around and all of that. I was looking at this paper earlier and hoping that there was like a link to some movies or to something, but I couldn't see anything. So these are 2D slices. You can see the scales here are in kilometers. So a quarter of a second after the bounce, this object is what? 500 on that side, 400. So this is about 1,000 kilometers wide at a quarter of a second. Turbulence. Well, these little spirals. That's fantastic.
It would have been great if they would give us like a movie or something.
Yeah, I'm going to have to look around to see if I can find something. Because, yeah, it's let's see, are these on the same scale? Yeah. Look at that. After 2/3 of a second, it's out over 6,000 kilometers. And it is interesting, right, that here's the center of the explosion, and a lot of it blows out one way, right? It's lobed. Anyway, I just think that these are pretty fabulous pictures. All a model, right? All a simulation. I think they should have kept the scale the same, right? Because the problem here is that they're keeping the visual size of the object the same, but changing the scale on the X and Y axis. Now, I don't know why. I mean, I guess they want to be able to see, details as much as they can. But I'd like to see a movie where this is actually shown expanding, right? That would be awesome. Then there's a bunch of plots and graphs, which get complicated really fast. Shock radius dipole. Pretty amazing. So this is the time after bounce, and this is 0.7 seconds way out here for those who are keeping score. Heating rate, gain in mass. heating efficiency, neutrino luminosity. Yeah, a lot of these things, you know, we'd have to look at a lot harder, right? I'd like to understand. Okay, so here's an actual explanation for what the different colors mean. I was curious about that. My browser's being a little slow.
Now on Discord, are you able to share text files?
I think so.
Because on my Discord, because what I did earlier was on shortwaving, I was on the shortwaves. I actually captured a Morse code text on the 40-meter handband.
Interesting. Very cool. So yeah, this actually describes what each of the colors is. So the white veil encompasses the expanding plumes, just interior to the shock radius. So the white, so the white is sort of the shock wave, right? So the blue plumes indicate a Y sub E spanning the interval 0.5 to 0.52. I don't know what a Y sub E is. But then there are these red caps where Y sub E is greater than 0.52. And the violet tail shows a low Y sub E. I see it there, yeah. Cool. I'm going to check on the chat really quick. Okay, cool. Yeah, hopefully she gets some clear skies. She hasn't been having a lot of luck, and she's got this brand new telescope, right, that she's like barely been able to use. Anyway, so yeah, I just think that these are pretty fantastic pictures. Very complicated, very intricate, and pretty interesting. Pretty interesting. Here's the center of the explosion, and you've got these weird lobes coming out of there. So yeah, who knows what's going on? All right. Well, I think I am going to depart these waters for now. I'm going to stop sharing. Yeah, I think it's about time to end this live stream for today. So thanks everybody for coming in, thinking and talking astronomy for a little while, each and every day, starting at 2 hours UTC and going hour. It usually goes a little bit more than an hour, but yeah, you know, once we get talking astronomical, it's just hard to stop. But I definitely will for now. So take care, everybody. Make sure to subscribe if you haven't. Thumbs up, thumbs down. Make some comments, and spread the word. Spread the word. We're trying to find like-minded people to come in and share the passion of astronomy. All right. Take care, everybody. I will see you on the spin. Bye.